Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
And I'm Norah. For math homework help, call in Bakersfield 636-4357. Everywhere else, call 866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, thank you for taking care of that, Norah. I know that Mickey and myself have a little problem with that every once in a while with all those sixes and stuff in there. But Norah, where do you go to school?
I go to Centennial High School.
And what year are you in?
I'm in the 9th grade.
So, first year in high school.
Yeah.
How do you like it?
It's fun. I'm liking all my teachers. I do a bunch of elective and sports. I play swim, water polo, and I'm also on the mock trial team.
Oh, so you're pretty busy.
Yeah, very busy.
So, is there anything that you have seen during your first year of high school that you're like, I want to do that now, or get into that later on?
Well, I'm really loving mock trial. We just recently won county. And
Hey, there you go. You got to be digging
you.
that.
I remember, yeah, you guys are going to state next? Is
Yeah.
that okay.
Yeah, I'm on the JV team, so hopefully I'll get to go with them to state next year, but I really want to be a lawyer when I'm older.
Oh, good. Well, that's good that you already have a plan.
So now I'm curious.
And-
Now you're involved in many different things. I mean, you said you do a lot of sports. Is there something specific in law that you want to practice, like a certain type of law?
I'd really love to become a corporate attorney. I recently met one who works for a law firm in LA. He gave me his business card too.
Awesome. Yeah.
Yeah.
I was curious if the sports had anything to do with, like, if you want to be an agent or something like that, and kind of that part of the law.
I'd be a swimmer too at the same time.
Right. Yeah. You're like, I negotiate my own contracts. I know what I'm worth. I got this.
So, you said swim and dive?
Swim and water polo.
Okay, and water polo. So do you prefer, I mean, because water polo is a pretty nasty sport as far
yeah.
as like the people that don't quite understand what's going on there.
Yeah.
It's pretty aggressive, let's say, underwater.
You get drowned a bunch.
That's one way to put it. There you go.
So do you drown a bunch or you make people drown a bunch?
Or do we
I
want to
drown a
plead
lot
the
of
fifth?
people.
Oh,
Oh,
no,
you
we're not
drown
pleading
it?
the fifth.
There you go.
All right,
yeah.
good.
Now we know what we're dealing with here today. All right. So you ready to help me out with our social media problem of the day?
Yes, of
All
course.
right, let's take a look at it together. So here it says solve for x, and we have 3, and we have, you know what exponents are.
Yes.
All right, good. So we have 3 to the 10th is equal to 3 to the 7th times something to the 3rd power. So we need to figure out what's in there for x, which is the, do you know what that number is called?
Oh, I'm assuming exponent.
Well, the exponent is the one up above,
Yeah.
and the larger number, the 3's all the way across so far are the base.
Okay.
All right. So we're looking for the base number. And when you see that, what's the first thing you think of, or what are you wondering, or what do you know?
Well, I'm assuming that we're going to be subtracting the 10 and the 7
Okay.
to get an answer, because all the other ones don't really look much possible, sense of process of elimination. I don't believe we'd be timesing the 10 by, oh, no, I looked at the problem wrong. Apologies. I'd assume we're probably adding the 3 and the 7.
Right.
Yeah.
Right.
I'm
Those
assuming.
exponents to get 10, because imagine if we had 3 and it's written 7 times,
Yes.
right? And we need to get to 3 and it's written 10 times.
Yeah.
How many more times do we need to write to 3? If we already wrote it 7 times and we need 10,
Yeah, we need 3 more times.
we need 3 more times.
Yeah.
But we need a 3 written down. We can't just have any number written down, right?
Okay.
So it's got to be the same base. So out of those options, which one do you think is correct? A, B, C, or D? Because we want the same base. We have 3 is the base to the 10th power.
Yeah.
Is equal to 3 is the base to the 7th power times something base to the 3rd power.
A? Because I'm a little bit confused.
Okay. Well, you want the same base.
Okay, the base
So
numbers
we just
are
look
the
at
10,
3 to the
7, and
10th.
3. Okay.
3 is the base.
Okay.
10 is the exponent.
Okay.
Okay. Now with exponents, when we're multiplying, we're just going to add the exponents to get the final one.
Yes.
But the bases have to be the same.
Okay,
So now what is the answer?
3.
You're a little more confident in that one?
Yeah, a little bit more now.
First one I was going to say, are you sure on that one? And we can always talk about it if you're
Yeah.
not, right? Which is why I wanted us to talk about it just a little bit more. So you're quite confident in A for 3.
Yes.
All right, let's take a look and see if indeed you are correct. There you go. First problem all done. I can guarantee you they'll all be kind of like that.
Oh, no.
That's a nervous right there. All right, 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Right now, it is time for today's Math in the News. And today's Math in the News, we have Dr. Singh-Uppal in with us from the California Cardiovascular Institute. And I know that we usually have one of you doctors in with us for the past couple of years around Valentine's Day, because we used to do things, and I was like, you know what? Everybody associates the heart with Valentine's Day, so I wanted to start bringing you guys in. And you guys have kind enough to come in for the last few years. So welcome today.
Thank you, Mike, for having me.
And what is your role at
California
Institute?
Cardiovascular Institute. I am a heart rhythm specialist. They call it a cardiac electrophysiologist. A fancy way of saying I'm an electrician of the heart.
Okay. And there's a lot of stuff that goes on with the heart, and a lot of things that you're looking at, and specific things based on what somebody is going in for.
Absolutely.
And one of the first things, so I can say, this is beautiful right here. This is
a pig heart. It's not a human heart. So
Right.
just showing you
But-
the chambers of the heart,
Right.
how heart is a muscle, is a pump. It's keeping us alive. The job of the heart is just to pump the blood so that all the nutrients and the oxygen can be supplied to all the organs and tissues. So it's the engine, just like a car's engine. It's pumping blood at a certain speed.
this is the main component.
This is the main component.
You need this. This isn't working right. It
Yep.
doesn't matter what
It
else.
stops, you stop.
You stop, right. So one of the things that happens is when people go in to you or any other doctor, one of the first things they do is usually take their blood pressure.
Correct.
And I know that I went in, and this is kind of how we were, because I needed to get my regular checkup and stuff. So we went in, and I had my blood pressure taken also. So we've got a little video of this right now. We can see up on the monitor me having my blood pressure taken. I'm
yeah.
not taking
So-
my blood pressure.
Yeah, it's a 3 we call the vital signs. The reason we call it the vital signs, blood pressure, your pulse rate, your oxygen, and your respiratory rate. Those are the 4 things which keeps us alive. So the first component is to check the blood pressure.
And there's a lot of things that you're looking at on that monitor when they showed that. One of the things that people often say is, well, your blood pressure is a little too high or it's too low. So there are certain parameters that you want in there. And I know that a lot of times, and for people with eagle eyes caught the numbers that were on the screen when I was in there,
Right.
there's a thing called the white coat syndrome.
That's a real thing. I see
Right.
a lot of white coat. Just coming to a cardiologist's office, let alone a regular doctor, everybody's blood pressure will go up. Now, guaranteed, you're just walking in an office and you're just putting you down and checking your blood pressure. So in an ideal world, you should be sitting down comfortably for a good 10, 15 minutes. And sitting in an arm's level, you check the blood pressure. That's the real way to check a blood pressure with a cough.
Okay, and I know that when I went a couple of minutes later into another room to have another test done, they took it again, and it was down about
coming
14
down, yeah.
points. So it's like, oh, that actually
But white coat is
happened right there.
you get anxious looking at a doctor, what's the news they're going to tell me? So you have your kidneys release a hormone called adrenaline. That adrenaline is going to make your heart race faster and increase your blood pressure.
All right, well, I know you've got a nice presentation
Yep.
here, so let's continue to go through this.
So you check your blood pressure, you check your oxygen levels, and then when they come to me, I'm an electrician, so this is how the heart's electrical representation on a piece of paper, called an electrocardiogram.
Okay.
Here, what we're looking at, what is your heart rhythm, at what rate. So there's a lot of mathematics. We're do the math. So the heart is a pump, is beating at a certain rate. So actually, we look at what rate the heart is beating. So this is an electrocardiogram called an EKG, and you're looking at these little spikes here. The spikes are telling you what is the top chamber, what is the bottom chamber, at what rate, how they look like.
Okay.
Through an EKG, we can determine if somebody's having a heart attack, any heart rhythm issues, is the heart running slow or heart running fast.
So as we're looking at this, what is this heart doing right here?
Correct. So I'm going to show you the math about it. So
Okay.
when we look at an EKG, we do simple maths. So 60,000 divided by the heart rate will give us a numbers in called milliseconds, or the vice versa. So I'm going to go back to that slide. Each of these small scares is a 40 millisecond. Each of these little bigger scares is 200 milliseconds. That's 1/5 of a second.
Okay.
So if you calculate the number of spikes starting here, this one spike, if you go back, 1, 2, 3, 4, that's 4 squares. 4 multiplied by 200 is 800 milliseconds. If you add a little bit, so this is 840 milliseconds between these two big spikes.
Gotcha.
If you 60,000 divided by 840 is 75 beats a minute. So this heart is beating at 75 beats a minute.
And what is the optimal? Is there an optimal?
So less than 60 beats a minute, we call it bradycardia. The heart is slow. Above 100 beats is tachycardia. So that's fast. So the average human heart should beat between 60 and 100.
Okay.
On an average, it's 70 beats a minute when we are standing right now.
Gotcha.
Okay. Again, then we look at the heart rate. We look at a lot of things on the EKG. This is the window to the heart. So we look at a lot of things. When they come to me, I'm looking at arrhythmias and a lot of other signs. This is just an animation showing you a beating human heart. The heartbeat starts right up in the top chamber called the sinus node. It's like a battery, like a car's battery. It will generate that impulses, which will travel through the heart muscle, go down a tiny wire. So me and you are born with a wire called an AV node, atrioventricular node.
Okay.
That node will conduct the electricity to the bottom chamber. So it's like a timing. The top beat needs to beat first. There's a time delay, and the bottom follows. So normal human heart, the top beats first, the bottom follows.
And there are times when that is off.
That's off. So example, in this example, showing you an atrial fibrillation. So something causes the top chamber to go in a very fast, irregular beats. That is the most common arrhythmias we deal on a daily basis. So top goes fast, the bottom starts going fast. So that's another common reason for tachycardia, rhythm. So that animation shows you the fibrillating human heart. Everything is chaotic, running, racing. And then this is an EKG, same thing. Remember I said EKG. So this EKG is showing you before, if you look at the old one, it was a nice one beat, and here everything is becoming
It's
chaotic.
all over, right.
This is what an atrial fibrillation EKG looks like.
Okay.
So this we can diagnose through an EKG, through an Apple Watch, through different cardio monitors and things like that.
And right now I know that we had an EKG done on me, and then this is what they were looking at right there when I was all hooked up,
Right.
doing my electric.
Exactly. So you start with the blood pressure, and now they're trying to figure out what is your heart doing from outside, right? That's what the heart's electricity is doing on an EKG. What I'm showing you here actually is a real human heart, and in a Langendorf perfused thing. So this is obviously from a cardiac transplant patient getting a new heart.
Okay.
So they take an old heart and they can connect it to this. So what you saw is that actually heart is fibrillating in AFib. And when you may have heard about, we can restore somebody's rhythm back to normal. We're doing cardioversion. We put paddles on the chest and we deliver electric shock. That's what you're showing here is the heart is fibrillating. This is the top chamber, this is the bottom chamber, and we can restore the rhythm back to normal.
Because that's what a lot of people will see. Like a lot of kids even will go, oh, you know what, I've seen people do that with these paddles or whatever, and that's what's going on.
Yes, because your heart is an abnormal rhythm. That paddle will deliver a very high electric shock. It stuns the heart for a fraction of a second so that the heart can start back in a normal rhythm. Again, there's a lot of mathematics which goes inside a human heart. We just don't see it, but a heart has its own. The heart is a beautiful organ where the physics, the chemistry of the ions brings out this beautiful biological organ. So there's a lot of channels. The heart rate is controlled by different channels in the heart. We call ion channels. That's what controls your sinus node, your AV node. So there are a lot of different clocks. You know, we're talking about mathematics here. So the heart has an oscillator, a simple oscillator, a harmonic oscillator, different oscillations. So that's what's controlled your heartbeats, 60 beats a minute, 70 beats a minute.
Okay.
So, and what I'm showing you here is an actual human heart in a real patient. We actually can go inside the heart, try to measure all the electricity and display on a 3D map. So what you're seeing here is a sinus node, normal propagation, how the electricity travels in a heart if somebody's interested to see. You see the beats start in the top chamber and then it just goes down. This is what I do day in out in a lot of our patients who have various arrhythmias or the fast heart rhythms.
And talking about the electric still, because one of the other things I had to do was after my EKG, they also started keeping track of that as I was on a treadmill. And what exactly, I mean, because you're trying to get the heart rate up to a certain number,
Right.
correct?
With the treadmill,
And here's what they're looking at right now.
With the treadmill, we're trying to figure out how fast your heart can go, number one. Number two, what's your blood pressure response to exercise? Number three, with the treadmill, we're trying to see if there is any evidence of blockages or the decreased blood supply to your heart, the electrocardiogram on a treadmill will become abnormal. We call STT changes. And number four, we're looking at your cardiorespiratory fitness. So a treadmill test is a beautiful test, stressing your heart's engine, your body, your car's engine, to figure out if the engine's going to break or are the chances to break.
And I passed mine.
Congratulations.
I mean, because I'm here, right? I mean,
You're here.
I passed mine, right? I mean, I did pretty well.
Yes.
Because I know that they said, all right, we need to get you up to a certain point, and we got there. but then they said, we need to stop you when you get to a certain point, even if I wanted to continue on.
Yes.
We did a little bit, but you don't want to go further than that because there is another mathematical equation to figure out those numbers, what your low is and your high, and not to go past that.
Absolutely. So the magic number is 220 minus the age of the patient. That's your top heart you want to achieve on a treadmill test.
So as an older man, that number gets...
That usually goes down.
Right, I was going to say, but if I can keep it up, then
you're in good shape.
Good.
Yeah.
All right, let's continue on.
So again, as I said, the heart is an engine, is pumping blood, has a battery called a sinus node, has a couple of wires. So those wires needs to be also stay in a good shape to conduct the electricity. So, and heart has many, many different branches. And then the speed of the electricity which travels in our human heart can be up to 3 to 4 meters per second. That's a lot of speed. The electricity has to go from top to bottom at certain speed.
Okay.
If something causes the speed to go down, medications, aging, heart attacks, your heart can slow down, and those patients may require pacemakers or other therapies. So just like cables, their heart has cables too. And this is how a human heart looks like. If you dissect the heart looking under a microscope, these are all the different cables which requires the whole heart to beat in a synchronous fashion.
About 5-second response, how often do you dissect the heart to learn?
When you go in your med school,
Earlier, right.
earlier in the things, but as a teaching, we usually dissect a pig heart or a sheep heart to show it the other students if they really want to know what goes inside the human heart. But
I'm just curious as to how often
not very
students
often,
would
yes.
be doing that. Okay.
So again, showing you an electrocardiogram, this is the most abnormal rhythm a patient can have. This is called ventricular tachycardia. The heart is going at a speed of, if you look at remember those numbers I told you, so this is almost around 200 beats a minute. Normal is 60 to 100, so this is bad news.
Yeah, because somebody's either exercising a lot or there's something going on.
Correct. This could be a sign of an old heart attack. There's a scar tissue inside the heart, and the electricity can become abnormal. So my goal is to go inside the heart, find where this is coming from, and I'm going to get rid of it.
Okay.
So in this example, what I'm showing you, this in a human heart, this little tiny thing is called a catheter. We take a piece of a cable which can deliver electrical energy to burn a piece of tissue. So in this patient, I went inside the heart, find the spot where the fast rhythm was coming from, and ablated it and cured the rhythm.
Okay, so you're just zapping it.
You're zapping
and
it.
being done with it.
Yeah, in this patient, it coming out from close to where the aortic valve, the main valve is. It's a piece of muscle. You go and burn the piece of muscle, and you can cure a patient from these deadly rhythms. And the last one, I think, this is another EKG, electrocardiogram. Again, remember, everything starts with an electrocardiogram for an electrician. So this is what we call an atrial flutter. This patient is in a fast rhythm. The top chambers are beating at 300 beats a minute. So what I'm going to show you next is, this is actually a pig heart. Electricity rotates around and around in this top chamber. And then we can go in the heart and find, this is a 3D map, and you can all tell the electricity is going in a counterclockwise direction. So that's
you can see that.
You can see that. So this is the cool thing we do. We make 3D maps. A lot of mathematics goes behind creating these maps. There's somebody who's mapping these things.
Right, and a lot of people might be like, I don't need to operate on something like that, but I can apply my skills to aid in this kind of
Exactly. So
medicine.
the people who do the mapping for us go to biomedical programs, biomedical engineering. So a lot of engineering things are happening behind this.
And one of the last things I know that I had to do was they did an ultrasound of mine also, and then we have some footage of that. And what you're looking at on the screen as they're looking at mine, and we can see how mine is going. And that looks pretty good, doesn't it, doctor? Right?
It does. From far away, it does very good, yes. But with an ultrasound, you're looking at the heart's strength, how strong the heart is pumping. You're looking at the valves, make sure they're not leaky, and then looking at the sizing of the heart. They're not getting bigger or smaller.
Okay. So I know that we're just about out of time. We certainly do appreciate you coming in and talking to us around Valentine's Day more about the heart. And I know that a lot of times people go, somebody broke my heart. So a heart can't actually be broken into pieces, but it can break by not functioning properly. And that's what you guys help take care of.
That's what we help. And there's a term for that. It's called a Takotsubo heart or a broken heart syndrome. When somebody gets really a bad emotional news or stress, the heart function suddenly goes down. The heart stops pumping blood immediately, or the function gets weaker. We call heart failure. In those cases, you just support the heart with medications, a lot of reassurance, and it'll get back to normal.
Right. So there is that.
There is.
It's like the white coat syndrome,
Yes,
same thing.
there is a broken heart syndrome.
And there it is, all right. Dr. Singh-Uppal, thank you for coming in.
Thank you, Mike, for having me.
We certainly do appreciate you guys every year coming around. We'll be back with more right after this.
Hi, my name is Marlene Flores, and I will be showing you how to represent inequalities on a number line. An inequality compares two expressions using symbols such as less than, greater than, less than or equal to, greater than or equal to, and not equal to. And I will be showing you how to represent these inequalities on a number line. Consider this situation. At Chevron, gas costs less than $4 during the winter. Let G be the price of gas. To begin this, you need a number line to plot the inequality less than $4. The key words are less than $4. The words less than indicates that 4 is not part of the solution. The inequality for the situation would be written as G is less than $4. On the number line, the circle would be placed on the 4, but the dot on the 4 does not have to be shaded in. If we pay attention to the wording less than 4, the number of gas will point to the left of the 4, but not including the 4, since the rest of the possible numbers are less than 4. Let's do another example. The price of a sandwich is $3 or more. Let S be the price of one sandwich. The word or indicates that 3 is part of the solution. The inequality for the situation would be written as S is greater than or equal to $3. The inequality for the situation would be greater than. On the number line, the circle would be placed on the 3, and it has to be shaded in. The price of a sandwich is $3 or more, so it includes the 3. The line will point to the right, because those are the possible prices greater than 3. And that's how you represent inequalities in real-world situations.
There we go, another great Let's Talk Math right there. 636-4357 is the phone number. Available most Tuesdays and Wednesdays throughout the regular school year. Norah, a freshman at Centennial High School, is our guest today. And how you doing?
I'm doing great.
You doing well? I think we're going to grab the calculator and send it over there for you.
Okay, thank you.
I know it was there, but we'll send it back over there for you right now.
All right, so as we get there, talk to me. I know we have our equation here, y equals x to the second power minus 2x minus 3. What's our goal today? What are we trying to do here?
So we're trying to get this equation graphed out and find its root values. So I'll write roots on the board. So we are going to want to start with the y-intercept. So as we see here, we have the a, the b, and the c. The c represents our y. So our y-intercept will be 0 minus 3 to represent our y-intercept. And then we have our
Positive 3 or negative 3?
positive 3.
Positive 3. Okay, so if a student was looking at it, they'd say, oh, well, I see minus 3. Why is it a positive instead? Talk us through that.
So whenever we have an equation like this, we are going to flip the signs.
Okay.
I'm not exactly sure why we do that, but that's just what I've been taught.
That's right. I remember back in it was just like, why is it flipping? And they're like, just do it, just do it. And I'm like, all right, I'll do it. All right, sounds good. Keep going then.
And then the next part of our equation is to find the axis of symmetry. So the equation that we are given is negative b over 2 times a. And as I'd stated earlier, that this is our a, so we're going to plug in a 1 since there is an exponent there. And whenever there is no exponent in front of the number, we can safely assume it's a 1.
Okay, so when I tell my 6th graders, like, hey, if there's no coefficient, it's a 1. Because
Yes.
at least there's an x there. We just don't always say 1x because it's just an x.
Exactly.
Okay.
And then we're going to plug in our b, which is negative 2. So we have the negative in front of the b, so whatever we plug in for b will ultimately be times by a negative. So
In other words, the opposite.
basically.
Okay.
So then we're going to get 2 over 2, which will equal 1. Now, we need to find the vertex of the equation, which this is probably the easiest part out of everything. We just plug in this equation right up at the top with the 1. So it is 1 to the power of 2 minus 2 times 1
Minus 3.
minus 3, yeah. So it'll be 1 minus 2 minus 3. So we're just going to do the 1 minus 2, which will equal negative 1 minus 3. Flip and have a negative, which I was always taught, keep, change, flip.
Right.
Well, keep, flip, change.
No, keep change, flip. I tell my kids it's Kentucky chicken that's fried, and they understand it.
And which you'll get negative 4.
So now negative 4, when you say vertex of negative 4, we said axis of symmetry is at positive 1. So when we talk about axis of symmetry, a lot of students may think, well, symmetry, like if I was to do a line down my face, the midpoint would be that y-axis. And for a lot of students in 6th, 7th grade, when you're reflecting across an axis, it's always just the y or the x. But in this case, it gets modified. It might shift to the right or the left, that axis of symmetry. Is that what you're saying?
Yes, it will. So our vertex will be 1, negative 4, which we can start by plotting that at 1, negative 4 right here.
Okay.
Next, we need to find each different vertices, which will be 4. So we're going to plug in our vertex. Sorry, I'm running out of room here.
You're good.
1, negative 4. This is our vertex. So we can start with that.
Okay.
I'll just erase this so I have some room.
So all that work to get the vertex, right? Is that all that work just
all
to
of
say,
this
here's
to
what we're
start
starting.
this.
Okay. Now, for students watching at home, we started with 1, negative 4. Now, that's all right. It happens.
First time working with these.
All right, so for the students watching at home, like I said, 1, negative 4 is kind of either our high point or our low point of the graph. Because it is a power of 2, we might see some actual 2 sides to it. Students might think a graph is always one direction or a line up or down, but now as we get into high school, higher level algebra, now we start to see that there are 2 sides and it starts to bend, and maybe even some waves now.
Yes, of course. Right now in my algebra class, we're learning parabolas, quadratics, absolute value, and linear equations. Right now we're doing a quadratic equation, I believe.
All right, so we're looking at the quadratic. We have positive 1. What are the other numbers we need to plug in? I'll plug them in for you if you want to count.
Yes, so we are going to do a 0 above the 1, then a negative 1, and then a 2 below the 1,
Okay.
and then a 3.
So we want 2 that are larger as x value and 2 that are less in x value to see which way it goes?
Yes.
Okay.
So we're going to start by plugging in the negative 1 into the equation, in which I am doing parenthesis negative, this isn't working.
That's right, I got you. We can do some quick PEMDAS, I
Okay.
believe in you. All right, so we have negative 1 to the second power, negative 1 times negative 1.
1.
Positive 1, all right, so we have positive 1, and we have negative 2 times negative 1, which will turn it into?
Positive 2.
Okay, so now we have 1 plus 2 minus 3, 1 plus 2.
3.
Minus 3?
0.
There we go, boom. All right, so we have negative 1, 0.
So
I
we'll
want you to
plot that right
Yep,
there.
negative 1, 0, beautiful. And now the next one, I want you to do it. Take the 0, plug it in, and if you want, you can kind of do the same thing, perform it, and then you can put the 3 pieces
Of course. So we're going to plug in 0 with the exponent, which 0 times 0 is
0.
0.
Okay.
And then 2 times 0, which is 0.
Beautiful.
So 0 again. And then we have a negative 3 left over. 0 minus negative 3 is just negative 3.
All right, so 0, we go down to negative 3.
Yes.
All right.
There. And then we have our next one, which is 2. So we're going to plug in 2 to the second power. Minus 2 to the 2 minus 3.
Yep.
So we're going to solve this out. So we have 4 minus 3, which these 4s will ultimately cancel out, and then we're left with negative 3.
All right, now, sorry, I'm just noticing here, again, it's been a couple years since I was doing algebra at this level. I am noticing a pattern, though. You know, even though I plugged in a negative 1, it was 0. 0 became negative 3. But on the flip side, when I plug in a 2, it also becomes negative 3.
Yes.
So is that a key that we're following the steps correctly, that we're beginning to see that same shape, but now on both sides? Because, if we put 2, negative 3, I notice that it's 2, negative 3, there we go. It's equidistant, it's symmetrical, it's a reflection on that axis of symmetry, like you said, which is now positive 1, because if we were to draw it, I'm betting it's going to pop, maybe not as steep, rather. Let me take that line back. But so I'm betting the next one is also going to be another one farther away. I'm going to guess it's 3?
No, it's going to be 0. And I'll explain why.
Oh, okay, I got you now.
So when we have these kinds of equations, the best way that we can check our own answers is if these two numbers, the 0 and the negative 1, are the same as these two numbers.
Okay.
If I plug, keep doing that. If I plug this in, we're going to do 3 to the power of 2 minus 2 times 3 minus 3. Now, when we do this, 3 times 3 is 9, minus 2 times 3, which is 6, minus 3. So that is 3 minus 3
Hey!
equals 0.
All right.
Blinked for a second there.
Then it goes to 3, 0.
Yep. So with these kinds of equations, we will always have the two sides reflecting each other because quadratics, absolute value, they're supposed to be the same on both sides, like a mirror.
Okay. So as you get into higher levels of algebra, you talked about doing quadratics, linear, absolute value. Does it change, like this is to the second power, and that's what's giving us that parabolic shape.
Yes.
When you go to the third power and fourth power, does it make a different shape because of the power difference?
We actually haven't been taught that, but I'd assume that it would start reflecting over the y, or it would cause maybe different shapes, but I don't frankly know.
And that's a little something that you guys can look into in the future, because right now you've done a wonderful job on that. You guys, great explanation on what was going on, and especially for some of the younger students that will be introduced to that soon, you kind of gave them a great introduction to what's going to be happening in that class that you're taking right now is a freshman at Centennial High School.
Yeah.
Nicely done for your great work. You've got yourself a pass to COM, so hopefully you have an opportunity to head out there sometime. Check out everything that is always new going on at COM. We'll be back with more right after this. All right, great math problem that Mickey and Aaron worked on right there. So, Norah, I don't know where I'm getting Aaron, because Aaron is on right now. They got Norah flipped backwards, and it's Aaron. You know that? Did you know that your name backwards
No,
is
I
Norah?
actually never thought of that.
Well, now we know
Norah
all
with
about
two
that.
A's on
Kind
there?
of, but it's like Anyway, Aaron and Condy, thank you for coming in from Kern County Public Health. You guys have been on the show before, so we do thank you for coming back in again this year. So we're going to talk a little bit about nutrition and numbers, because all of that stuff is instrumental in how our whole body works and our heart.
Absolutely.
All right, so let's take a look at what do we know?
So did you know? So we know that diet and heart disease work together, and what we eat absolutely affects our health and our long-term health. So did you know, for statistical purposes, that 9 out of 10 children eat more sodium than recommended? So this raises the risk of heart disease long-term. 2,000 milligrams of sodium is a teaspoon of sodium. So that's not very much, but we're often eating twice that.
Right, I was going to say, I know it says 9 out of 10 kids, but 9 out of 10 people probably,
Yes.
right? Because adults also.
Absolutely, but staggering that we're starting at such an early age, learning behavior
Right,
that we
because
then
most people
take to
wouldn't think
adulthood.
of kids having too much salt intake.
Absolutely. So that's a staggering number in and of itself. But not only that, but 5 in 10 children drink more than recommended amount of sugar-sweetened beverages. So 50% of kids are eating far too much added sugar. For 4 to 6-year-olds, that would be like 5 sugar cubes would be your daily allotment of sugar. Oftentimes, 4 to 6-year-olds are eating twice, 3 times that amount.
Right, they're having that at a sitting, let's say.
Yeah,
instead of the
sometimes
whole
at
day.
one drink.
Right.
So, and then 7 to 10-year-olds and 11 plus, 6 cubes and 7 cubes respectively, oftentimes kids are not following the allocations for added sugar that we have, and long term that puts stress on your heart.
And a lot of times that's because of the availability that they have and the cost of it.
Yes.
It's an easier thing for them to get, so that's what they do, intake.
Exactly, and it's everywhere. We see sugar and added sugar beverages, sweetened snacks. They're kind of everywhere we look, so they're very easily accessible and delicious. So
Right.
Kids are all over them. 1 in 6 children ages 8 to 17 years old has high blood pressure, which again, long hypertension puts long-term stress on your heart, can raise your risk for heart disease.
And I was going to say, looking through the slides before we started, that was an astonishing one to me because you usually don't think of kids as having high blood pressure
Exactly.
that young.
Yes. And if we have it that young, that raises the risk later in adulthood. They've had high blood pressure for
For a
maybe
long
20
time.
years. Your
Right.
heart has been kind of elevated risk for a long time. And then finally here, 2 out of every 10 children in the United States are obese or overweight as well. Kind of goes hand in hand with some of these other slides, maybe bad lifestyle habits, but much of the excess weight is due to poor diet, overeating, and again, long-term strain on the heart can lead to heart disease.
Right. And I know it says, 2 out of 10. And I think different parts of the United States, different parts of the world also, based on diet, which is everything that you were just talking about, is the biggest impact on that. Because hereditary, you've got some things coming to you that you can't control.
Yes.
But there are many more
Lifestyle
things that you
factors.
can control.
Yes, and a lot of it is diet related, so we do
Right.
want to kind of figure out what we can do, to pose less risk for heart disease for ourselves long
All right.
term.
And there are ways to fix this.
Yes,
All
absolutely.
right. Condy?
Yes, there are ways. Heart health and fitness. We need to exercise in order to have a healthy heart. This is a fun fact for the kids. Your heart beats 100,000 times a day, and that is 35 million gallons a year. So can you imagine how much blood we're actually pumping? So that is a fact. Okay. The other one is important to know how our heart works, and it is about and how it looks like. And I told everybody when the kids that it's like the side of your fist. You can put in there, that's your heart. To care for your heart, to take care of your heart. So this is a fact that I also like, that it pumps 1.5 gallons of blood every minute. Every minute, wow. So if you go home, you get a gallon of milk and another half a gallon of milk. In 1 minute, that's what happens. So the kids love to see those things so they can get excited about the quantity of blood pumping. And this one is very, very, a little disappointing that 9 out of 10 kids don't get enough exercise for their hearts in our days. And we need to make a difference. We need to make sure that the kids are working out, that they are taking this as an important part of their life, less sedentary life. More playing outdoors. I know it's a little different nowadays, but yes, we want to make sure that our kids are moving constantly. And here I have another slide that I love. The exercise help us because it's a muscle and it needs to be exercised, just like the biceps and triceps, and we do our quads because we want to get those legs strong. Same with your heart. You don't see it, but it's the most powerful and the most important muscle you will have. Then we want to make sure that we take good care of it. So exercise pumps more energy. It gives you more energy because you get more oxygen through your body. And a strong heart helps you run faster, play longer, and feel great. And I told everybody, especially I told the kids, do you know that there are kids that are older? I can be older but younger inside if I exercise. And they're like, can we stay young forever? Yes, a lot, almost. If you exercise, you stay young because you're still mobile and you have more energy. And what makes you younger is that energy. So our kids need to be more energized in our days. And I believe exercise is the most important part. Nutrition and exercise, they cannot go without each other. Boom, boom, together. Without it, doesn't work. And let's see what else. So I like to make it fun. So this is like a little way of the exercise for 4 minutes for kids. So I created this little fun exercise. For example, they can make it fun. Exercise needs to be, I want to do it. No, they will not do it. They need to make, then we need to have something exciting for them. And this one in here is a normal jumping jack, and I'm going to show it just very quickly. So we do with it. We we do a normal jumping jack, but this is for the kids, so we gotta make it even funner. So we can do a jumping jacks, but crossing the legs and crossing the arms. Pa, pa, pa. And they can do it for a minute. They can also do it like this. They don't have to jump. So, show them that there's alternatives, so there's no failure when we're teaching our family and friends, not just kids. You can add, as long as we're moving, our heart
And
is
even
moving.
what you're doing right now, Condy, because instead of actually jumping or moving fast, if a kid is just moving in that manner,
Yes.
that is also going to help right there, because they might think, I can't do it that fast.
Exactly. So it's finding ways that the kids keep moving. It doesn't have to be one way, but different ways of adapting to their needs, listening to their bodies, listening to their needs, where they are. And this one here is the frog rock jump. It's so funny. You become a frog, but you have to teach, everybody needs to know how to squat before we do anything. So squat and then rock. Squat and become a rock. So the kids can have fun, and they don't want to jump. It's okay. This already is giving you, your heart rate is going up, and it's giving you that energy. This is fun. When we play with animals, you can make sounds. And if they don't want to jump, it's okay. They can do this. But it's the movement that they're getting already here for their hearts. And freestyle. This is the most powerful. Dancing is the best. I think if the kids come and dance more.
You just do what comes naturally to you, right? It just doesn't matter how you move, just as long as you keep on moving right there.
Yes.
And I think you brought up a great point, coming back over, Condy, is that you can make yourself a little younger by doing all of that work, eating the right things, getting in a little bit of movement. You might be older, but you can live younger. Mm-hmm. And that's the whole thing right there. Mindset also, and being willing to try different things as far as your diet goes, moving a little more. It doesn't have to be a lot all at once. Just slowly get into it a little bit and get into that habit when you're young so that it's not such a big deal as you continually get older.
Becomes a good habit, right, over
Right.
time?
Yeah, you don't even have to think about it. It's just something that you automatically do. Aaron, Condy, thank you very much for coming in from Kern County Public Health. We'll be back with more right after this.
What is space weather? Space weather comes from the sun. The sun is always emitting material, solar wind, plasmas, and shoots it off throughout the solar system. Our sun is a star, like the many you see up in the sky at night. It's just way closer than those, about 93 million miles away. The sun is a yellow dwarf star and is 10,000 degrees Fahrenheit. It is an ordinary star, one of 100 billion stars in our own galaxy, the Milky Way. The sun is the center of our solar system, and its gravity holds that solar system together. The energy of the sun is generated at its core. The next layer is called the radioactive zone, and then the convection zone, where hot air rises and cold air sinks like water boiling in a pot. Energy continues to travel out to the photosphere, the visible surface of the sun. Above that is the chromosphere and the corona, which stretches 5 million miles around the sun, where space weather comes from. There are 3 common types of solar eruptive phenomenon: sunspots, coronal mass ejections, and solar flares. A sunspot is a temporary dark spot on the surface of the sun. It turns dark because it's much cooler than the surrounding area. They are regions of very, very concentrated magnetic fields that get super twisted up, and they can grow and shrink and can change shape. Coronal mass ejections are big solar eruptions and shoot lots of plasma and high electromagnetic field from the sun's corona, the outermost layer of the sun. A solar flare is a very bright flash of light that has very, very fast particles, energizing these small amounts of particles to almost the speed of light. So it's different from a coronal mass ejection, which is a very large eruption of billions of tons of material. Solar flares and coronal mass ejections can be really disruptive to our satellites in space and electrical systems here on Earth because of the electromagnetic fields. To learn more about these fields, let's ask Dr. Carrie Black from the US National Science Foundation. She's a plasma physicist that studies the sun. Dr. Black, can you teach us about the solar magnetic fields?
Okay, what are solar magnetic fields? Well, we're going to get into the basics of plasma physics with this. So, Plasmas are collections of charged particles. So they're electrically charged particles. And when they move, they create magnetic fields. And the sun is made up of different types of plasma. And it's real complicated on the sun because we have small scale magnetic fields and then we have very, very large magnetic fields. So I think everybody or most people are familiar with the idea of a magnetic field from a bar magnet. In quiet times, at solar minimum, the sun is essentially a bar magnet. The magnetic field is kind of like this. But because it's not a solid body, it's not made of a solid material, it's made of this plasma, right? It's twisting and moving, and so the magnetic fields get all sorts of twisted up, which is what gives us things like sunspots and coronal mass ejections.
Thank you, Dr. Black. That was very helpful. So, because the particles are so energetic during the different types of eruptions, when the waves of particles hits a satellite, it can damage the electrical systems and other components. Studying the solar environment can be exciting because space weather changes every day, and with proper safety glasses, you can observe the sun too.
All right, we've had some great guests in studio today, but the best one is Norah because she's here doing work all hour long. You ready?
Yeah,
All right, now, you said that you haven't done geometry in a little while.
I haven't. We've only been doing algebra this year.
Well, it's a big day for you there, sister, because we're going to do a little bit right now. You ready?
Wonderful.
Surface area. All right, let's go.
Oh, let's see.
All right, so we have 7 1 by 1 by 1 unit cubes that are glued together to create the figure shown here, including one cube in the middle that you can't see. What is the surface area of the figure? What are your thoughts?
I'd assume you just use 7 times 1 since all the area of this, all the areas combined of the 7 cubes are all equal to 1. So you'd probably just do 7 times 1.
So when they say 1 by 1 by 1, right, so let's take this cube right here on the end, this one sticking out. 1 means that this edge is 1 unit long. The next one means it's 1 unit tall and 1 unit wide.
Okay.
So do you remember the formula for area?
Length times width.
Right, length times width. So what's our length here?
1.
Width?
1.
So the area of this single side is?
1.
What about this side?
1.
This side?
1.
The one on the bottom?
1.
Other side?
1.
So this one cube
Okay.
actually has how many?
5 sides.
5 sides, and each one is worth 1, so 5 times 1?
5.
So this actual cube has a whole surface area of
5.
5 units squared.
Okay.
So let's use that. How can we figure out the surface area of the entire piece?
That makes a lot more sense now.
All right, go for it.
I'm assuming it's going to be 7 times 5, which will equal
What makes you say that?
35. Well, okay, so it says that there are 7 cubes that are glued together. And if we can use the context of this problem, obviously, 7. So there are 7 cubes in total in this figure.
Okay.
And since I've just explained to me that the surface area of 1 cube is 5, we can just do 7 times 5 to get our area.
And what's our total area again?
35.
Be a little more specific. 35 ponies, 35 dragons.
Square inches.
Square
Cubed.
units.
Units.
There we go. So
But-
75. Yes.
Hold
Mike?
on.
75?
Sorry, 35.
You said 35 because there were 7 cubes, but you can't see one.
Oh, so there
So
are 8
how many
cubes.
are visible?
No. So there are 7 cubes. You're right. Not 8.
Okay.
There's 7. But remember, that cube is in the middle.
Okay.
Can we actually see the surface of that cube that's in the middle?
No, you can't.
So can we count that?
No.
No.
'Cause it's
So-
inside.
Exactly. So how many are actually exposed? We have 1 in the front, 1 on the back, 3, 4, 5, 6. So it's really...
6 cubes, so it'd be 30 then.
Jury says?
You got 30 now?
Yes.
I'm cool with 30.
There you go. You gotta see what survey says.
Let's go.
Survey. We only survey one guy. It's either right or wrong. All right.
There you go. You've got 1 minute for the bottom problem.
So we have
Got it.
3 sets of 8 identical cubes. So it's 8 cubes rearranged 3 different ways. Which figure has the greatest surface area without doing math?
Without doing math.
Without actually adding it up to figure out this is the surface area, what do you think we could do to determine which one has the greatest surface area visible?
I'm going to go with C.
Why?
Just because of how compact it is, and with everything being squished together, I would assume that if we're just counting for one side of the surface area, that since C looks to have the greatest, that I would choose C.
So let's go back to the top one real fast. Remember we had that 7th cube was in the middle, but did any of it actually count?
No.
Why not?
because it was inside the figure.
And we can't actually see the surface area, right?
Exactly.
So let's look at C. Everywhere these touch like this, that is an entire surface area between these that we don't get to count. So we
Okay.
have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 surface areas that we don't get to use.
Okay.
Would you want to change your answer now that we've discussed that concept?
Yes, I'm going
Okay.
to go with A then, because we can see all the surface area.
All of them?
Yes.
What about the one they're touching? Does the ones that, so like,
So
this
all those
piece
ones
and that-
touching don't count.
well, no, the ones, so like, let's look at the end cap. We have a top, bottom, left, right, and a front, but do we
Okay.
get the back of it?
No.
What about this one? Do we get the top, bottom, left, and right?
No, we only get the two, the side and the top.
Right, well, we got the back side and the bottom, right?
Okay.
So it's still there. We may not be able to see it, but we understand that it's visible.
Okay.
So it is going to be A, and the reason is because those pieces, when we touch them end to end, those ones do not count. But like on this one, when I put a block together, I'm not only blocking one face, I'm now blocking a second face because that other block is touching it.
Oh,
So this
okay.
one, we might have a top, bottom, a left side, and a right side that we can't see. But on this one, I only have a top, bottom, left, and right. But that one might have all four, but then the other one only has 1, 2, 3, because the
Okay.
right side's blocked, left side's blocked, and the back side is blocked.
Oh, okay. That
Right.
makes more sense.
So we don't even have to do math to determine which one is the greatest surface area. We can just simply try to figure out which one has the least amount of surface area controlled or obstructed by another cube.
Okay.
And I was going to stop you there and go on because I had another problem for you, but I think we're going to stick right here with this one. So you originally said C, and we heard why you wanted to go with C, and then after Mickey talked about what you cannot see in C, you went with A.
Yes.
Why would you not even consider B?
Well, I didn't consider B because you only get these three surfaces, the left side, the right side, and the top side. And as Mickey was explaining, that we can only see these sides right here. So we'd only get this small little surface area. And if these don't count,
Right, like the ones on the
Quite-
inside that are touching.
yeah, it'd be quite a small surface area like we did in this problem up here. That's what my reasoning would be for it.
Right, and that perfectly works like that, right? So there's a lot of different ways you can look at it. And like Mickey said, without doing math, actually calculating what the surface area was, you can just deduce which one had the most surface area based on what you guys did. And that's an important way to approach mathematics. Looking at it logically, what's missing? You can't see all of that, so that has the most missing. That we can see the most. I don't even care how many there are, but I know I can get the most looking at that surface area right there.
Right, and the big thing that I would say is if you were to see a problem like this and think, oh, I've seen this, I don't worry about it, it's 3. The only reason we can do this without actually calculating it is because these are
Identical.
identical. They have the same number. Now, if all of a sudden this one had 10 and this one had 8 and this one had 6, okay, now we have a problem. We actually have to calculate. But because it's 8 of the same ones, that's okay to do the logic with it. But if it has
There
a
we
different
go.
number for each one, you got to calculate.
Nicely
Got it.
done. And we'll be back with more right after this.
Now this is a familiar scene. The sun's heat causes water from plants, lakes, and oceans to turn from a liquid to a vapor. High in the atmosphere, the water vapor then cools down and condenses from a gas back into a liquid. The liquid water then falls back to the surface in the form of rain, snow, ice, or hail. Water runs off into streams, lakes, and oceans, or is stored in the ground or in snowpack. This is the water cycle, and it describes how our most vital resource moves through the whole Earth system. But like most things in our world, when we look at the tiny parts that make up the whole, we can learn a lot more about the phenomena. Take the shape of a single raindrop. Small droplets of water in the atmosphere are spherical in shape due to the surface tension or skin of the water molecules. As these droplets grow, they become heavier and start to fall through the air. As they fall, the raindrop collides with other drops and continues to get bigger. These larger raindrops fall through the air faster. The wind resistance on the underside of the drop causes the bottom of the drop to flatten, resulting in the drop looking like a hamburger bun. As the drop continues to fall and grow, at some point it becomes too large for the surface tension to hold it together, so the raindrop breaks apart into smaller spherical drops. Investigating the processes we can't see with the naked eye is nothing new. Science and technology drive each other forward and often lead to insights and discoveries along the way. With the invention of high-speed photography, we finally saw the most basic elements of our watery planet in action. Understanding how a tiny raindrop falls through the atmosphere does more than debunk the myth that a raindrop falls like a teardrop. It actually makes a difference when it comes to measuring precipitation. In particular, for ground radars. Ground radars look at the sides of the raindrops and then estimate the vertical and horizontal size. A heavier, flatter drop allows radars to identify heavier precipitation. In fact, the two radars on board the GPM satellite can also measure drop sizes from space, and so a more accurate look at raindrops gives us a more accurate look at how global rainfall is shaping up.
All right, we've had some great guests in studio with us today. We had Dr. Singh-Uppal from the California Cardiovascular Institute. We have Aaron and Condy from Kern County Public Health in to visit with us also. But our most important guest, Norah, a freshman from Centennial High School, was in studio with us all hour today. You are now an ambassador for Do the Math. You know what that means?
Not frankly, what is it?
Well, you are now an ambassador, which means you have to inform people about Do the Math when you are out and about.
Okay,
You can do that.
I definitely can.
We even gave you a uniform.
You did.
I did, that's right. Gave her a uniform, so she's got it. She knows all about that now. So when you're wearing that, and people are like, hey, Norah, what's up with that? You know, you'd be like, hey, Do the Math. You never heard about that? They're in their 23rd season. I'll tell you, this is all the stuff they do. Fabulous stuff. Take a look at this date. I was on it.
Gladly.
All right. You a master of the Rubik's Cube?
No, I suck at them.
Okay. Well, you know what?
It's geometry.
I
You gotta
think the
get
rest
one.
of us
You'll
do
be fine.
also.
It's geometry.
You're not talking any Rubik's Cube master here, but you do have an exclusive Do the Math Rubik's Cube. So hopefully you can, in some spare time, I don't know how much spare time you can have as a freshman in high school right now for the next 8 years or whatever. But anyway, hopefully you will have a bit of time to check that out. And if you have some time to check things out, especially you want to check on your health screenings. You don't have time to go to a doctor, you can't make an appointment at a doctor. There are mobile health clinics provided by Kern County Public Health. Those are going on all this week. There actually is one coming up tomorrow at the Dream Center on 19th Street, right near the Do the Math Studios. And then another one on Thursday on East Truxton at the Blanton Education Center, kind of a little bit east of the downtown. And it's easy to find. It's on East Truxton Avenue. But you can see the dates and times for the various mobile health clinics right there. And there's a lot of different screenings you can go and check out. Mobile health clinics always available by Kern County Public Health, and those are the latest ones coming up right there. Norah, you did some fabulous work in studio today, and that geometry didn't frighten you too much, did it?
No, it
that
didn't.
surface area right there. See, everything comes back, right? You're like, oh yeah, it's been a while since I've done it. But it's just like riding a bike, right?
Yeah, exactly.
Did you learn a little something today?
I did. It was a good refresher.
Good. And did you have fun today?
I did. I'd love to come back.
Well, perhaps we will have time to have you come back. Perhaps as a sophomore, you can come back again.
Oh, yeah, I'd love
Sound
that.
good? All right, cool. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.